Okay, the first question was simply definitions, and I just used the glossary of the textbook to find these. You could have also Googled them, but the thing is that we want to define them um, according to what we're studying. And I rewrote the question to be a better question for the next time I give the test, so that statistic, uh, you didn't go into the science of statistics. So this is what I was expecting for that first question. For the second question, an observational study, we observe and measure the specific characteristics, but we don't do any manipulation. While in an experiment, there's an application of some treatment, and then we observed what happens after the treatment. So there's a treatment implied on the experimental subjects. That treatment might be light level, it might be uh, music, it might be scent, it might be a drug. It's imposed on the people. They got to do it if they're in the experimental group. Now, the treatment is given to the experimental group while a inactive substance is given to the placebo group, meaning that they are getting ineffective treatment, but they don't know which it is. It's important in this question that on the exam, that tells the proportion of questions that Marla got correct. Well, when we talk about percentile, that's a rank. So she scored better than 70% of the people who took the test. Okay, so on the question about the department store, to find the z-score, you took the $6,000 in sales minus the mean divided by the standard deviation, and you get a -2 for the z-score for Tuesday. And this is what I was looking for the picture. Okay, now um, we can find the percentile rank by finding the proportion of the curve that lies below the z-score of a -2. And you could do that a couple different ways. You could use Table A, you could use StatCrunch, you could use the 68, 95, 99.7 rule, and you will see that um, there's about a little more than 2% of the distribution that's below that. Now, D, was Tuesday an unusual day? You could say no, it wasn't, because it was still within plus or minus two standard deviation units of the mean. Or you could have said yes, Tuesday was unusual, since it would happen about 2.3% of the time. Um, so either answer was correct, but it was your reasoning I was looking for. And what percent of the daily sales should be under 12,000? Well, half of the day should be under 12,000 because that's your mean. So now when we talk about the researcher, oh man, that uh we didn't have people, we had people. Sorry about the typo. But we had a vegetarian diet and a non-vegetarian diet. Uh, if there was no effect, we'd get this outcome one time in 100. So, does the result have statistical significance? Yes, it does. Because it would rarely happen, only 1 in 100 times, if there were truly no difference. Now, again, your answer for this second part about practical significance, um, if your reasoning was good, I took either answer. Now, I said there was not practical significance because I Googled blood pressure, and um, systolic blood pressure of 124 is not in the healthy range on the information I found. It is in the pre-hypertension range, and so is the 138. So that's what I said. Some of you told me that it was practically significant because 124 was in the healthy range. Um, Again, this is a take home test, so when you don't know something, like I don't have a lot of information about blood pressure, um, Google it, see what you find. That's what you can do on an open book test. Would an observational study or experiment be more appropriate to investigate the effects on fertilizer on plant growth? There was a right answer for this one, and it's the experiment because if we did an experiment with plants in a controlled uh, atmosphere, we would be able to compare what the fertilizer did. So if we had this in a greenhouse and all the plants were in the same place, they got the same amount of light, the same amount of water, the same temperature, and the only thing that was different was the amounts of fertilizer. That would be the best way to do it. An observational study, if we did an observational study out in the field, how are you going to control how much fertilizer each plant gets? Uh, how do you know how much they get? And is the light, is the temperature, is the soil the same? So we want to minimize as many uh, confounding variables as we can, and the best way to do that is with an experiment. Okay, and again, this had a typo. This should have been 2001, 2006, and 2003. And some of you pointed that out, and I took your answer because it was good. Some of you went with it the way it looked. And the shape of the distribution is slightly skewed because it stretches out to the right. So if we knew this data, the mean should be larger because the mean is pulled toward the tail. Okay? Now, this one I kind of crowded everything together. So here is what my stem and leaf plot show. Those of you who did this by hand, some of you left out the 8. So even if a stem has no members, it still needs to be represented. Here is my box plot. Uh, you can see I used StatCrunch. The mean was 55.2, the median was 56. For part A, besides the stem and leaf, it's kind of skewed, so I would have expected the mean score to be bigger, but it wasn't. But that's what I wanted you to do, is just think about it and put it out there. So we got the median, the 5-number summary is going to be the minimum 36, quartile 1 is 40, the median is 56, quartile 3 is 66, and the maximum is 96. We already looked at the box plot. The interquartile range is between quartile 1 and quartile 3, which in this case was 26, and I made a calculation error in the beginning. When we do the upper fence and lower fence, we're adding 1.5 interquartile range above the upper fence or below, below the lower fence. And so my upper fence should be 105, my lower fence should be 1. And since we don't have any data that's above that, there are no outliers. Okay, so this is what I was looking for. When we're talking about a normal distribution, we know it follows the 68, 95, 99.7 rule. Now, I drew that on there for the next question. All I was looking for here was your standard deviation units and then giving me the values for the 20-year-old females in the United States. Okay, and then for the last question, we use that same distribution And this time I did want the 68, 95, 99.7 rule. So question A says, between what values do the upper arm lengths of females over 20 who are 95% of the time? That wording isn't good, but I think you got there. So 95 is between plus and minus 2 standard deviation units, so that's where we get the 31.6 to the 40 centimeters. Now, what percent of women over 20 have upper arm length less than 33.7? Well, 33.7 is right here. Okay, so there's a couple different ways to do it. I looked at it and said, okay, let's start with 50%. That's all of this. And let's take away this little piece of 34% that isn't in that, and that's how I got the 16%. Okay. Other way to do it is, if 68% is here, 100 minus 68 is going to be 32%. 32% divided by 2 is 16%. So that's how we get to that number. I hope this helps.